Hello guys, my name is Bilal and this is your very first STL2 tutorial. In this tutorial, I will be a little bit talking about what STL is and I will show you guys some of the popular games that are built using STL. STL stands for Simple Direct Media Layer and it is so far and so forth the most powerful C++ graphics library, and some of the most popular games are built using STL. You can program both 2D and 3D games using STL. And one of the most cool thing about STL is that you can write less and you can get more. Another cool thing about STL is that all the commands and instruction it has are very simple and easy to learn. One important thing I should tell you guys. STL is not only a special C++ graphics library, but there are many other programming languages like Android, Java, Python and many other popular programming languages support STL. So it is a good news for you guys that when you will learn it how to program using C++, you can then use it in Android, Java, Python and other programming languages which support STL. What we need to do is that we simply download STL setup file from STL website, add it to the programming language which support it, and enjoy by writing simple codes and make some beautiful and awesome 2D and 3D games. Enough talking about STL. Now let me show you guys some of the very popular games that are designed in STL. So for this I will go to my PC, D drive, and here is the folder where I have kept everything to teach you guys. So I will open it, and in this folder I have kept all these games to show you guys. So let me show you guys this one first. This is a 2D Super Mario game. Beautiful graphics, great control over objects, and I know that many of you guys are familiar with this types of game and many other games like this. This is another popular STL game. It is a 3D game and its name is Urban Terror. Again, awesome graphics, great control over everything. And this game, I don't know its name, but it is very similar to Urban Terror. It's also an STL game. And this menu system from an unknown game is also programmed using STL. And this is a fighting 2D helicopter game, helicopter game. And this one is a simple helicopter game. And this one is a scary game. Dying Light is also made in STL. And maybe some of you guys won't like to play this because it's full of terror. It's a very scary game to play. Okay, so I believe that you guys now realize the power of STL and you should have gained a bit of knowledge about what STL is and which type of games you can make using it. At the end, I want to tell you guys that this course is going to be awesome and I promise you guys that you will understand each and everything I will teach you. You guys just need to follow along, be strict to it, it's going to be awesome. So thank you guys so much for watching and I will see you guys next time. What's up guys, my name is Bilal and this is your second STL2 tutorial, and in this tutorial I will be teaching you guys how to include STL to your C++ compiler. But before we include STL to a C++ compiler, we need a C++ compiler called dev-C++. So for this, go ahead and open your internet browser. Now right here just type dev-C++ forge, yeah. And now just click this very first link. And now just click here, which is this download button, and your downloading will begin automatically. Well, I'm not going to download it because I already have one setup downloaded, but you guys download it and then come back. And now once you have downloaded it, just close it and go to your download section. And now this is your dev-C++ setup. Well, you guys just open it and go through all installation process. It's a very simple process, nothing weird and complicated in it. Just click few times next and finally click finish to complete the installation process. but I'm not going through this process because I already have my dev C++ installed on my computer. And once you are done with the installation process, go to the section where you have downloaded your dev C++, and by default it is installed in your C drive, program files, and right here. Well, I suggest you guys to create a shortcut on your desktop. So to create shortcut, click create shortcut and click yes. Then close it, and here is the shortcut created for your dev. And now it's time to download and add STL to our compiler. Well, to download STL, again, go ahead and open your internet browser and just type here STL2 download. Just open it and click this very first link. And now just come down a little bit. And now in the development library, just click this very second link, which is this Ming W link. So just click here to download it. So I will also click it. And now my downloading has started begin. And now I'm pausing the screen and I will come back after my downloading gets complete. Now once your downloading is complete, you should see this compressed file with name stl2.devel.2.0.5.mingw.tar. So just open it. And now you guys need to extract it. So click this extract to and click OK. And it will take less than a minute. And it is now completed, so close it. So now just open it, again open it, and also open your dev C++ compiler. And now we are going to add STL2 to our compiler. So just follow along. First click this tool option, and then compiler option, and then just go to this directories tab. And now for your binaries tab, go back again here. And now if your operating system is 32-bit, you need to open this file. And if your operating system is 64-bit, you need to open this file. And since my operating system is 64-bit, so I have opened my 64-bit file. And now just open this bin folder and press Ctrl L on your keyboard, and then press Ctrl C. Then go to your dev C++ compiler, point your cursor here and press Ctrl V. And now since I already have added this, so I will not click on this button. You guys click on this button to add it. So now go to your libraries and now go back again here and open this lib folder. Now again press Ctrl L, Ctrl C, and Ctrl V right here. Again, I will not click on this button. You guys need to click on this button to add it. And now click on this C++ include tab. Again, go back here, press back, open this folder, and again press Ctrl L, Ctrl C, and paste it right here and add it. And now your STL has been successfully added to your compiler. So now after adding it, click OK. And now it's time to include it in your project as well. So first create a project, new project, and just name this project as STL or STL2, and this will be my empty C++ project, and now click OK. And now I already have made a folder where I will teach you guys everything. So I will also keep this project in that folder, and that folder is in my PC, D drive, and right here. So now click open and save. So there we go. And now instead of keeping this tab as untitled, name it anything you want. Well, now you have created your project and it's now time to add STL to that project. So to add STL to that project, right click on this project and go to project options and just click on this directories tab. And now for this library directories, go here, click on this lib folder, again press Ctrl L, Ctrl C, go to your dev compiler and paste it right here, and don't forget to click on this add button. Well, now click on this tab, include directories tab, go here, open this include folder, and now again press Ctrl L, Ctrl C, go to your dev compiler and paste it. And please do not forget to add it. And now one last job you guys need to do is to go to your parameter tabs and point your cursor here, and now copy everything in the folder name linker which I have provided you guys and paste it right here. And right now I'm pausing my screen because I forgot where I have placed that linker folder in my computer. So welcome back guys, and finally I have found that folder named linker and paste everything which was inside it. And now just click on OK, and now you have got everything ready. And now one final job I promise you guys need to do is to go to your tools, compiler options, directories, and include, put here this backslash STL2, and now click again STL and remove this, delete, because we do not need it now. And it's STL2, click add, delete this and click OK. Similarly, go to your compiler option, project options, directories tab, and include, and put this backslash STL2, add it, and now remove this first one out by clicking on it and deleting it. Yeah, so now click OK. And now go to the bin folder which is inside your STL2 folder which you have extracted. Just open that bin folder. Now there should be one file named stl.dll or stldel. Just copy it and paste it in the folder where you have created your project. But I'm not going to do this because I and you guys have created the project in different destinations. But be cautious to place your stl.del file in the same location where you have created your project, because it's an executable STL file, so it must be placed in your project location. Similarly, copy and paste all the images I have provided you guys in your project location and nowhere else. In the next tutorial, we will finally start working on STL. So up till then, thank you guys so much for watching and I will see you guys next time. Hello guys, my name is Bilal and this is your third STL tutorial, and in this tutorial we will be displaying a STL window and displaying it on screen for some time, maybe for few seconds. Now, whenever we use a library in C++, remember we have to include it before using it, and since STL is a C++ library, so we have to include it before using it. So first include STL library by typing, where is my cursor, hash include stl.h. Now just tap your main function and give these two parameters or arguments to your main. Now whenever you are using STL in dev, you have to give these two parameters or arguments to your main for some obvious reason, which of course I will tell you guys in the tutorials to come. Now we are going to write our very first STL instruction by initializing STL, and to initialize STL, STL has something called STL init. So whenever you initialize STL, just simply type STL init and it takes the parameter STL init video. Now do not worry about this STL init video, just type it as I have typed. Now we have initialized our STL, and let us assume that we have written all of our code after initializing STL, and now we want to stop working on STL, or we want to quit STL. So to quit STL, STL has something called STL quit. Remember, we must have to write all of our STL code in between STL init and STL quit. Any STL instruction outside of it will not be considered by the compiler. So I will create a STL window in between STL init and STL quit. So to create STL window, just simply type STL window, and this one is this instance. I will type here window, you may type anything you want, equal to STL create window. Now take 6 parameters. The first parameter it takes is a string, and it is basically the title of your window, your STL window. So give any title to your STL window. I will type the game. The second parameter it takes is where you want your window to appear along x-axis. So let's say I want to appear my window along x-axis at 400 pixels. So just type here 400. The third parameter it takes is where you want your window to appear along y-axis. So let's say I want my window to appear along y-axis at 400 pixels. Now, the fourth and the fifth parameter it takes is basically the width and height respectively of your window. So give any appropriate size to your window of your choice. Well, I will give 640 width and 480 height. Now how long you want your STL window to appear on your computer screen? So for this, STL has something called STL delay. STL delay, and it takes the time in milliseconds. So this 2000 or you may say 5000 means only 5 seconds. And now we have got everything ready, so just go ahead and run it. and you may see that a window has appeared on our screen, and it will definitely disappear after 5 seconds, and it disappeared after 5 seconds. So now let's make our window to appear at the center of our screen. Now basically these two arguments are responsible for the position of our STL window on the screen. So just first remove this one and type here STL window position undefined, and just copy it, copy and paste it here for y-axis. Now just go ahead and run it, and now you see that the window has appeared on the center of our screen for 5 seconds. Okay, now let me explain you guys one last time. We first included STL library in our code so that we can use all STL instruction. Then we initialize STL so that we can start using STL instruction. Then we created a window, and to create window just type STL window, make its instance and make it equal to STL create window. Now it takes 6 parameters. The first parameter it takes is the title of your window. The second and the third parameter it takes is responsible for the position of your window on the screen. And I have typed here STL window position undefined. It means that I am not giving you any position. You yourself make it center along X and Y axis. And these two parameters define the size of your STL window along X and Y axis. And this is for how long you want your window to appear on the screen, and it takes the time in milliseconds. So this 5000 means basically 5 seconds. And this is for quitting STL after you have written all of your STL code. Now at the end I will explain two things which I haven't covered yet. The first one is the STL window instance or object. Well, you guys will be wondering why you have made pointer instance and put a star before the instance. Well, for this you guys need to understand pointers first, which is a basic C++ knowledge, and I have provided you a link for this because this course is all about STL and not pointers. But don't worry, we always make pointer instance for our STL window and some other built-in classes which we will cover in the tutorials to come. Another thing is the last argument of our STL window. Well, it is a very shitty argument and is out of our scope. So just type 0 for that last argument. And now it's time to say thank you to you guys for watching this tutorial, and I will see you guys next time. Hello guys, my name is Bilal and this is your 4th STL2 tutorial. In this tutorial, I will be teaching you guys about a very important STL command called STL renderer. But before I explain it, let me first tell you what basically happens when you refresh a particular location of your computer. Let's say I refresh my desktop. Now what basically happens is that everything you see here are now up to date as soon as I refresh my desktop. Now similar is the case with STL renderer. What it does is that it refreshes your STL window 40 to 60 times per second depending upon your operating system. If your operating system is 32-bit, it may update your STL window 40 to 50 times per second. And if your operating system is 64-bit, it should update your STL window 50 to 60 times per second. And this number of updates per second in computer programming is called frame per second, or in short you may say FPS. STL renderer is a structure, or you may say struct, that handles all rendering. It is tied to a STL window, so it can only render within that STL window. It also keeps tracks of the settings related to the rendering. Let me run it by first increasing the delay time to 6 seconds or so. Run it. You may see that a window has appeared, but it is not updating, and the reason behind it is that we haven't used STL renderer till now, which I'm going to use it right now. Now to use STL renderer, STL has something called STL renderer, and then make its pointer instance, name anything you wish, and make it equal to STL create renderer. Now it takes 3 parameters. Now the first parameter it takes is the instance of your STL window, and we have that instance name as window, so just tap here window. Now the second parameter it takes is for selecting the display driver, and the -1 here means that select the first display driver found on your computer. Now the third parameter is the additional setting of the renderer, and by 0 we mean that we do not require any additional setting on the renderer. You do not need to worry about these two parameters because they are closely related to hardware. You just simply tap here -1 and 0 and never ever forget to put a semicolon at the end of each statement. I hope that STL render is now clear to us. I will tell you more about it after a few tutorials, but that's it for this tutorial. So thank you guys so much for watching, and I will see you guys next time. Hello guys, my name is Bilal and this is your 6th STL2 tutorial. In this tutorial I will be teaching you guys something called STL surface and STL texture. Let me first explain what STL surface is. STL surface represents an area, or you may say a memory, where an image can be drawn to. Same stuff? Okay, let me try once again. STL surface provides you with an area where you draw image. You may consider it as a canvas where an artist draw an image. But here in this case you have to draw, or you may say paste the image. So without wasting any time, let us provide an area, or you may surface, to an image. So to provide a surface, or you may say an area to an image, STL is something called STL surface. Surface, again, make it instance, name whatever instance you want to make. I will make it ball and make it equal to STL load BMP. Now to which image you want to provide a surface on area to, just write the name of that image in the parameter, and the name of that image is ball, and the extension of it is .bmp. Now what BMP means, BMP simply stands for bitmap image, and it is the extension of that image. Now you must be wondering why the heck Bilal you are using only .bmp images. Why not .png, .jpeg or .gig? Well, the reason behind it is that by default STL support only .bmp images. If you want to use the images other than .bmp, then you need to include a special library called STL image to your project and to your compiler as well. But in this tutorial series I will be using .bmp images only because they are very transparent, neat and clean, and they can do the job for us. Now we have a surface, it's time to have an image on it. So to have an image on it, STL has something called STL texture. Just make its pointer instance, name anything you want, and make it equal to STL create texture from surface. Now it takes 2 parameters. The first parameter it takes is the instance of your STL renderer, and the name of the instance of the STL renderer is renderer. So just tap here renderer, and the second parameter it takes is the instance of your STL surface, and we have this name as ball. So just tap here ball and put a semicolon at the end. Let me explain you guys the purpose of these two parameters. The purpose of this first parameter renderer is that since our ball will be changing its location again and again, that is, it will be moving on the screen, so it's need to be updated. So that's why we are using here renderer. Now the purpose of the second parameter is that it draws that image on our surface. Simple enough. Now remember that every STL texture needs to be updated, and we have to tell which image we are going to draw on our surface. And to tell which image to draw on the surface, we need to provide the instance of the STL surface. So it automatically knows that yes, this is the image which I need to draw on the surface. Now what this means is that since we are creating texture from the surface, we have a surface, now we need to create texture from it. So that's why we are using here STL create texture from the surface. Remember, whenever you want to have an image on the screen, you must provide a surface, or in real programming sense, you have to provide a memory equal to the size of that image which we want to appear on our STL screen. I think that I have made the purpose of STL surface and STL texture very clear to you guys, and that was the purpose of that tutorial too. So thank you guys so much for watching, and I will see you guys next time. What's up guys, my name is Bilal and this is your 5th STL tutorial, and in this short tutorial I will teach you guys something about STL rect. Well, rect is a short form of rectangle, and it defines two purposes. The first purpose of it is where you want your image to appear along X and Y axis. The second purpose of it is how big you want your image to appear on the screen. So without wasting any time, let's move to our code. Now to define the position and size of your image on your STL window, STL is something called, what the heck is this? STL rect, and make its instance. I will make my instance as ball rect. Now notice here that I am not making here pointer instance, and the reason behind it is that at any time you want to pass the reference of an object and not its copy to a function, you make a pointer instance. And for your better understanding, I provided you a link which will make you clear what is the difference between pointer instance and simple instance. Because this tutorial series is not about learning pointers and object, it's all about STL. Now how STL rect define the position and size of your image? Well, there are two ways. One way is to put an equal sign, put these curly braces. Now since STL rect, you may say rectangle, has 4 sides, so it also takes 4 parameters. The first 2 parameters it takes is the position of your image along X and Y axis on your STL window. So let's type here 20 along X axis and 30 along Y axis. Now the next 2 parameters is the height and width of your image. So let's type here 20 for height and 30 for width, and do not forget to put a semicolon at the end. Now you should know that we haven't just yet tell STL to put this image on that particular location. We have only defined layout params using STL rect. Now we have to apply these layout param for this image or any other image later on. Now one last thing, if you are struggling in making the difference between simple instance and pointer instance, let me a bit make it easier for you guys. Now you just need to remember that in STL you always make a simple instance for STL rect and pointer instance for STL surface, STL texture, STL window, and STL renderer. So yeah, I think that's it for this tutorial. So thank you guys so much for watching, and I will see you guys next time. Hello guys, my name is Bilal and this is your 7th STL tutorial. In this tutorial, we will be finally displaying our ball image on our STL screen, because we have got now everything ready. All we need to do is to copy everything and paste it on our STL screen. And for this, STL has 2 commands, STL render copy and STL render present. Let me first explain what STL render copy is. Well, STL render copy copies the texture to the current rendering target. See stuff? Okay. STL render copy copies or it keeps the information of your texture so that later on it can be presented or pasted on your STL screen. Remember that for every texture which is to be presented on the screen, it must be copied first and only then it can be presented on the screen. So let's move forward and copy your ball texture. And to copy your ball texture, STL has a function called STL render copy. So just type here STL render copy. Now take 4 parameters. The first parameter it takes is the instance of your STL render, and we have this name as renderer. And why it takes this parameter? Well, because the ball texture needs to be updated again and again. That is, the ball will be moving on our screen and will be changing its position constantly. Remember that in almost 99.99% of the games, all the texture or images needs to be updated again and again. So that's why we are passing the instance of your STL renderer. Now the second parameter it takes is which image you want to copy. Just give me the name of that instance which holds the information of that texture, and the name of that instance which holds the information of this image is ball texture. So just type here ball texture. Now the third and fourth parameter is concerned about the location of your image on the screen. The third parameter demands that okay, I know I need to place the image on some area on the screen, but from where I should get the source so that I can place that texture on a specified location. And since we have directly specified one source, and it is this 20 along x-axis and 30 along y-axis, so no need to get any source from anywhere, from my computer or any other place. So just type here null, N-U-L-L. The fourth parameter is concerned about the destination of our texture, and our destination of our ball texture is 20 along x-axis and 30 along y-axis, and this ball rector holds the information of this. So just type here, where is and ball rect, and put a semicolon at the end to complete the statement. Okay, now let me explain what STL render present is. Well, STL render present show every image which is copied in STL render copy. And since we have only one image copied in our STL render copy, so it will show only one image on the screen. So just type here STL render present, and it takes the instance of your STL renderer, and you should know why and what a render can do to the image, and put a semicolon at the end. So now just go ahead and run it, and you may see an image which has appeared 20 along x-axis and 30 along y-axis. So congratulations to you guys, you have done a fantastic job by displaying an image, your very first image on STL window. But remember, there's still a lot more to go, so you guys need to stick along. It's gonna be awesome. So thank you guys so much for watching, and I will see you guys next time. Hello guys, my name is Bilal, and this is your 8th STL2 tutorial. In this tutorial, we will be learning the most fundamental and important topic of game programming, and it is called event handling. Well, we do not want our STL window to disappear after 6 seconds. Rather, we want to disappear after we press, or after I press this close button. But before we do this, let me first explain what events are. An event is an action, and it occurs as a result of user action, such as clicking a mouse button, key press, etc. And that event is detected by our program. Particularly most modern applications that run in Mac and Windows environment are said to be event driven because they are designed to respond. For example, let's say I'm playing a Super Mario game and my Mario will move only when I press the right key. That it will respond to an event and will move. This is because I program my Mario to move only when I press the right arrow key. Now there are different types of events, for example mouse event, keyboard event, joystick event, touchscreen event, device event, etc. But in this course I will be teaching you guys only keyboard events. So let's begin our work by removing this one first on because we do not need it anymore. And now I'm going to make a function called event handler. Void event handler. It takes no argument. Now what this function will do, that it will listen or wait or detect for any kind of event to occur. Okay, be attention guys. This function need to be called again and again in every frame, that is 50 to 60 times per second depending upon your frame per second rate, because in every frame we want to check whether an event has occurred or not. And how to call this function again and again, let me show you guys right now. And for this I'm going to make a global type bool variable called quit and make it equal to false. And now I'm going to start a while loop in the main function, which will call event handler function again and again, while not quit, which means that while quit is equal to false, and it is equal to false because I have made quit equal to false. So this condition is true. So when this condition is true, call the function event handler. And now this while loop is basically our game loop. All the collision and movement will be controlled from this loop. So now let's go back to our event handler function. Now we have made this function, and now how this function will detect an event? Well, for this STL has a built-in function called STL poll event, and as an argument it takes the event which has occurred. So snap here event. Now remember, this event is an event which has occurred as a result of user action, and this STL poll event is a built-in function, and it takes the argument, it takes an event which has occurred as a result of user action. Now we have to tell STL that if the event which has occurred is equal to if event dot type is equal to STL quit, which means that if I press the close button of my STL window, then you make quit equal to true. And when quit is equal to true, this condition will get false and it will come out of this loop and it will quit over STL window. Now just run it to check whether it works or not. And I'm getting an error because I haven't declared this object, and that object is basically the event which has occurred as a result of user action. And now from where this object is coming from? Well, this object is coming from a built-in class called STL event, and just type here event, and now just go ahead and run it. Come on, why is not working? There we go. And now it will not exact after 6 seconds. It will exact only when I press this close button, which means that, there we go, when I press the close button it will exact. Awesome. Okay, now let me explain you guys one last time. I make this function called event handler, and this function is responsible for listening to an event, and we need to call this function again and again to check for all kinds of events. And this while loop which is basically our game loop, will call the event handler function again and again. And this here means that while quit is equal to false, which means while our game is not closed or quit and is running, you call this function again and again. I hope that you guys now got a better idea of what is going on, and when you will move forward, your understanding will get better and better. But for now, I want to thank you guys so much for watching, and I will see you guys next time. Hello guys, my name is Bilal, and this is your 9th STL tutorial. In this tutorial, we will be setting our background image for our game. Well, I recommend that you guys do this by yourself and then come back. Anyhow, I'm also going to do this for you guys. So first create a surface by typing STL surface and name your instance as BK, which stands for background, equal to STL load BMP, and the name of that image is BK dot BMP. And I believe that you guys know what STL surface, what STL texture, and STL render copy means. Now create your texture by typing STL texture and name your instance as background texture equal to, why don't I copy this? Copy and paste, and just name this thing as BK. And now you just need to copy this texture by typing STL render copy render background texture, which means BK texture, null. And before I specify this parameter, I need to tell STL about the position of my background image on STL screen and the size of my image as well. And how we do this? So come on, you have 2 seconds time to guess. So we do this by typing STL rect and just name it as BK rect, which stands for background rect, and for the X location 0 and 0. Okay. Now what will be the height and width of that image? Since it is our background image, that is it will appear on our whole screen, so its height and width should be equal to the height and width of our STL window. So just type here 640 by 480, and now just type here BK rect and put a semicolon at the end. So now just go ahead and run it, and we will have a beautiful background image set in. And getting an error, this is because I haven't put a semicolon at the end. So just go ahead and run it again, and come on. And now you may see our beautiful background image. Well, it's okay if you don't like this image. You may try another one of your choice, but this image I guess is a bit pretty, so I will be using this image. And now what I'm thinking is that I should increase the height and width of my STL window and image as well. So how I will do this? So maybe to 800 by 600 pixels, and I'll do the same here, 800 by 600 pixels. Now just go ahead and run it. and I think that this window is looking more beautiful than the previous than our previous window. So now just close it. And now some of you guys must be wondering that, okay Bilal, you have used stl render copy 2 times. Why have you not stl render present 2 times? Well, the reason behind it is that stl render present or shows every texture which is copied. So here this texture is copied and this texture is copied. So stl render present will present or shows only these 2 textures. So you have to use stl render present only 1 time in your code. And now why I have specified here 0 0? Well, I leave this thing to you guys to understand it by yourself by tapping different values instead of 0 and 0. But even if you don't understand, please let me know. I will surely answer you. And for now, I want to thank you guys so much for watching, and I will see you guys next time. What's up guys, my name is Bilal and this is your 10th STL tutorial. In this tutorial, we will be moving our ball on the screen. Let me first explain what we are going to do right now. Well, you guys should know when the ball will be moving, it means that it will be changing its position again and again. And we know that the position of any image is determined by strrect. And basically these 2 arguments here are responsible for the position of our ball. So now this position needs to be changed in every frame so that our ball image keep on moving. So this strrect must be put in our game loop to keep the ball moving and changing its position. So let me cut this whole statement. Cut and paste it in my game loop. Control V. Now we need here 2 variables which keep on changing its position again and again. So for this I'm going to make 2 global variables. Int, let's name it as ball x, and let's keep the initial value to 10. Int ball y equal to 10. Now instead of direct values, just type here ball x and ball y. Ball x and ball y. Now what will be the velocity of the ball, that at which rate it will be moving on the screen? So for this I'm going to make 2 global variables again and just name it as ball velocity at x is equal to 1 pixels and int ball velocity at y is equal to 1 pixels. And now I'm going to make a function which will keep updating the x and y position of my ball. So I'm going to name my function as move ball, and the return time of it will be void move ball, takes no argument. And now just type here ball x is equal to ball x plus ball velocity x, and just copy this whole statement, copy, control V, and just ball y and y. Now this function also needs to be called again and again so that the x and y value of ball keeps on updating. So just call this function move ball in my game loop. Now one last job we need to do is that since our ball is getting a new position, so that position needs to be copied and presented again and again on the screen. So this render copy and this render copy and this render present must also be in our game loop. So just copy this both statements, control C, and paste it right here. Now just remove it from here because we do not need it anymore. But I should have cut this. This is embarrassing. There we go. And now our ball should move on the screen. And there we go. It moves on the screen, but it is leaving an impression behind. And this is because we have updated the position of our ball, but we haven't cleared our last position. And how to clear it? Well, for this, STL is a built-in function called STL render clear, and it takes a parameter of our STL renderer. Sorry, the instance of our STL renderer. So now just go ahead and run it again. And now you may see that ball is not leaving any impression behind, and this is because we are clearing our window in every frame. But now we have encountered another problem, and that is our background image is not there anymore, and this is because our STL render clear function clears our background image. So we need to copy and present our background texture again and again. So just close this. So just copy this whole statement. Copy and paste it right here. Paste. So now just go ahead and run it again. And yeah, that's what we want for this tutorial. But now let me explain you guys one last time what I have done. Well, first of all, the X and Y position of the ball is kept 10. And then we call this function moveBall, which will increment the value of X and Y position by 1. And then we copy our board texture, that is our background texture and ball texture. And then we present it on our screen. Now here, the ball will be at position 11 and 11 instead of 10 and 10. And then we clear our whole window. Now it will come back again here. It will call this function and will increment the value of X and Y position from 11 to 12. And then we will copy both texture again and then present it on the screen. Now here our ball texture will be at position 12 and 12 instead of 11. And then it will clear the screen again, and so on. And this will continue as long as this condition gets false. I believe that you guys now got a better understanding of what is going on. If it doesn't make sense for the first time, then please watch this tutorial again. But for now, I want to thank you guys so much for watching, and in the next tutorial my brother will be here to teach you guys something which is very awesome. So again, thank you guys so much for watching, and I will see you guys next time.
Hello guys, this is Umar Khan and welcome to the 11th tutorial of STL. In this tutorial, I'm gonna teach you guys how the ball will rebounce along the wall of the screen. Let me show you how it works. See, the ball ran straight away, but we don't want the ball to run straight away. We want to rebounce it along the walls of the screen here, 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 and anywhere else along the wall of the screen. Now let us practically see how are we gonna accomplish our task. And now to accomplish our task, we will define 4 global variables right here. These are the 4 global variables that are in background width, background height, background width minimum, and background height minimum. And why have I initialized background width and background height minimum values to 0? You will come to know about it later. Now to go on with the main task, let us make a function named ball collision. White ball collision. It will take no parameters, and here is the body for it. Now we will define the if condition for it. If ball x, that is the position of the ball at x, is less than the background width minimum value, then the ball will rebounce. Now this condition over here is valid for this side only when the x coordinate value equals to 0. Now we will make a condition valid for this side when the x coordinate value equals the maximum value which we have set equal to 800 right here. Now for the other side, let's make the if condition that will be made by ORing it with this condition, and that will be made only with the background width. That is OR ball position at x coordinate is greater than the background width minus 30. I'll come back to this 30 later, but first let me tell you what these 2 conditions will do with the ball. For this, let me run this program. The ball still ran straight away because we have not yet mention its y coordinates. These two conditions will make the ball to circulate between this towards this region and not allowing it to go further away. Now what this 30 has to do in here? This 30 is actually the width of the ball. This 30 will make sure that the ball will bounce back when its outer surface hits the wall of the screen. If this 30 is missing here, there is a chance that the ball will go inside and its inner surface will collide with the wall of the screen and its inner surface will bounce back. Now what do we want if any of these two conditions is satisfied? We want the ball to bounce back. In other words, we want its velocity to be negative or reversed. For this, ball velocity x equals to negative ball velocity x. This negative sign over here will reverse the velocity of the ball and the ball will now move in the opposite direction. Now we will make a if condition that is for the y coordinates. That is, if ball position at y is less than bkh, we will use the background height here, and if its minimum value is less than the ball position at y, the ball has to bounce back. Now to go on with the second condition, that if the ball position at y is greater than the background height minus 30, and this 30 has the same properties as it was for the x coordinates. Now the body for this if condition, and we will again reverse its velocity. The ball velocity at y equal to negative ball velocity at y. This negative sign again will reverse the velocity and the ball will move in the opposite direction now. Now we will call these functions from the game loop. And why will we call it from the game loop? Because we want to check at every frame that whether a collision has occurred with the walls or not. We will call these functions here ball collision with no parameters. And now why have we called this ball collision functions below the move ball? Because move ball will determine that whether the ball has moved or not. After that, the ball collision function will check that whether a collision has occurred with the walls or not. Now the job we want to do is almost complete, and now let me run this program for you. Oh my god! We have an error here and I am missing here. Let us run it again. See how beautiful it is. The ball is bouncing exactly the way we want to do it. So thank you guys for watching and stay tuned for the next tutorial. Bye bye.
What's up guys, my name is Bilal and this is your 12th STL tutorial. In this tutorial, we will be making our pad, and the pad will move to the left when I press the left arrow key, and the pad will move to the right when I press the right arrow key. So let's begin our work by first creating surface for our pad by copying this. This is because I'm lazy, and name it as pad, and the name of that image is pad. And then create texture. For this I'm going to again copy this. Copy what I have done, Control Z, Control V, and then just rename this as pad and just type here pad. And now we need to specify the position and size of our pad, obviously by strrect. But before I do this, let me make first two global variables right here. I think here it will be much better. So just type here int pad x is equal to background width divided by 2, and for the y position Step here, background height, which is basically this. Now, why I have divided this by 2? Well, this is the width of my whole screen. Now, I want my bat to appear at the center of the screen, so I will divide this width by 2 so that my bat, so that the position of my bat at X will appear right here. And for this, I'm going to minus at least 30. Well, this is because I want my bat to appear a bit above the screen. So now it's time to create STL rect. Bit more below, right here. STL rect bat rect is equal to bat X, bat Y, and for the for the width 60, and for the height 30. Now just copy this texture right here, STL render, copy, render bat texture, null, ampersand, bat rect. And now why I have used this whole statement in my game loop? Well, this is because the bat image also needs to be updated again and again. Now remember that in game programming, every image needs to be updated again and again because they are constantly changing its position. So we need to put all of our images in our main game loop. So now it's time to run it and check it whether it works or not. And now you may see an image which has appeared at the center along x-axis and at the bottom along y-axis. But I'm thinking that I should teach how the bat moves in the next tutorial, because if I teach it in this tutorial will get much longer. So for now, I want to thank you guys so much for watching, and I will see you guys next time. What's up guys, my name is Bilal and this is your 13th STL tutorial. In this tutorial, we will make our bat move on the screen when I press the left and right arrow key. And you should know that pressing any key is an event, and to handle events we have made a built-in function called event handler, which will handle all of our events. But before we handle events, let me first correct a little mistake which I have made in my previous tutorial. Where it is, there we go. Well, I have made this STL rect outside of the game loop. It must be inside of my game loop because the bat will be changing its position again and again. So similar to ball rect, we need to put bat rect also inside of our game loop. So now just go to your event handler function and type here else if the type of event just occurred is equal to STL key down, which means that if any key is pressed, so you come inside. Now we know that a key press event has occurred, but we don't know which key is pressed. So you come inside and make another if statement, that if event dot key symbol dot symbol is equal to STL k left, and the position of bat at x coordinate is greater than 0, then what you going to do? Well, then move the bat along x-axis 2 pixels to the left. So just type here bat x equal to bat x -2. Now let me explain you guys what I have done. First of all, I have checked that if any of my key is pressed, that is the type of event is equal to key down or STL key down or STL key press. So you come inside and check which of your key is pressed, and to check which of your key is pressed, you have to do this weird thing in STL. So I have stated here that if event.key symbol, which means that if your key pressed is equal to the left arrow key, and if the position of bat at X is greater than 0. Okay, now let me explain. Now this is the location of X coordinate on the screen where I have pointed my pointer. The bat will move only to the left if its position at X is greater than 0, because we don't want our bat to move to the left after my 0 location, that is my 0x position. So if this bat position at X is greater than 0, which means that the bat can be anywhere else but not here, then change the location of X by 2 pixels, that is move the bat 2 pixels to the left of the screen. And now why I have used here -2? Well, this is a very fundamental and basic mathematics knowledge that at positive X coordinate the value of X always decreases to the left. So now make another if statement for our right arrow key, that is if event dot key symbol, which means that if the key press is equal to STLK right, which means that if my right arrow key is pressed and bat X is less than background width, which is 800 I think, or maybe 600 -60, then what you going to do? Well, is simply increment this value by 2. Equal to, there we go. Oh my god, this is embarrassing. Well, this -60 is the width of our bat, which we have already declared in our bat rect. And now I leave this condition up to you guys to understand it by yourself. Because if you understood this condition, then this condition is very obvious. And as a hint, I am telling you to just type here different values which are less than 60. So just see how genius you are. And even if you don't understand, please let me know. I will surely answer you. So now just go ahead and run it. And now the bat is moving so nicely and smoothly on the screen. When I press the right arrow key, it is moving to the right, and when I press the left arrow key, it is moving to the left. In the next tutorial, we will see how the bat and the ball collision work, how the ball collide with the bat. So stay tuned, and thank you guys so much for watching, and I will see you guys next time. What's up guys, my name is Bilal and this is your 14th STL2 tutorial. In this tutorial, we will be making our ball collide with our bat. So far, our ball is moving on the screen and it is only colliding with the walls of our screen. In this tutorial, we will be making our ball collide with the bat, and I will be showing you how to make it happen. I will be making my bat ball collision logic in my ball collision function. So just go to your ball collision function and come right here. First we will make one integer variable called ball scaling and assign it a value of 20, and I will explain it later why I have assigned it a value of 20. And then just type here if the ball at y plus my ball scaling is greater than or equal to my bat position at y and my ball at y plus ball scaling is less than or equal to position of bat at y plus 30, and this 30 is basically the height of my bat, and the position of ball at x plus my ball scaling is greater than or equal to bat x, and the position of my ball at x plus the ball scaling is less than or equal to position of bat at x plus 60, and this 60 is the width of my bat. Then what you're going to do, you simply reverse the velocity of the ball at y position. Ball velocity y is equal to negative ball velocity y. Well, this condition seems very weird, but this condition is not as that much weird, so let me explain it to you guys right now. Well, let's first forget this ball scaling for a minute and just consider the position of ball at y is greater than or equal to the position of bat at y. To explain this condition, I should show you the image of my ball which I have on my desktop. So I will open it. Well, let us first assume that this blue is our bat and this is our ball image. Let us again assume that the bat is at position 600 on the screen and the ball is at position 300 on the screen. And I'm stating in my condition that if the position of my ball at y becomes greater than the position of my bat at y, for example, let's say my ball is here and then it comes here, then here, and then finally it comes here. Now here the position of my bat and the position of my ball are equal. So I am stating if this position becomes equal or the position of my ball becomes a bit greater than the position of my bat at y, then you simply reverse the direction of my ball. Now as soon as the position of the ball at y equals the position of the bat at y-axis, we want the ball to reverse. In other words, we want it to rebounce, because if the position of the ball at y-axis become greater than the position of the bat at y-axis, then the ball will go inside the bat, which is opposite of what we want. So we need to reverse its velocity. And now why we are using ball scaling and adding it to the position of the ball at y? Well, this is because it is possible that this side of the ball collides with the bat, but we want only this side of the bat to collide with the bat. So to make it sure that only this side collides with the bat, we are using ball scaling, which is basically this thing. So now just close it and come to our code again. Well, I hope that this condition is now clear to you guys. Now why I am adding the here 30? Well, this is because, let me first run it. I want my ball to collide with the upper side of my bat and not at the bottom side of my bat. So I'm using here 30 to make it sure that my ball collides only with the top side of my bat and not with the bottom side of my bat. Well, I hope that this condition is now clear to you guys. Now why I am adding the here 30? Well, this is because, let me first run it. I want my ball to collide with the upper side of my bat and not at the bottom side of my bat. So I'm using here 30 to make it sure that my ball collides only with the top side of my bat and not with the bottom side of my bat. Well, I hope that this condition is now clear to you guys. Now why I am adding the here 30? Well, this is because, let me first run it. I want my ball to collide with the upper side of my bat and not at the bottom side of my bat. So I'm using here 30 to make it sure that my ball collides only with the top side of my bat and not with the bottom side of my bat. Now this whole condition is for checking the collision of the ball the collision of the ball with the bat at y-axis, and now this condition is for checking the collision of the bat along x-axis. But I leave this condition to you guys, up to you guys, because if this condition is clear to you guys, this condition is 99.9% similar to this condition. And now I'm going to run it to check whether my bat ball collision works or not. So let the ball to come. Oh my god. There we go. Now the ball is perfectly colliding with the bat. Well, this is a bat ball game. You may play it for the whole day, but for now I want to thank you guys so much for watching, and I will see you guys in the next tutorial. What's up guys, my name is Bilal and this is your 15th STL tutorial. In this tutorial we will be displaying our breaks on the screen. So just let's begin our work by making two global variables right here for the width and height of our break. So break width is equal to 80 pixels and break height is equal to 35. So now just create the surface for the break by typing STL surface and name it as break, and now make the instance only global, and we will initialize this instance in our main function as we did before. So now create texture, STL texture, name it as break texture. Now create STL rect for break global as well, break rect. So why not I make this instance as an array type and give it a size of 3 rows and 5 columns. I think 6 here will be better. Well, you will get a better understanding of it a minute later, but now let me make a function called initialize break to give this instance different values. So just make a function called void initialize break, and it takes no argument. Now the value of this instance array at 0 0 location will be break rect, at location 0 0 will be 50 50 for the x and y position of my break, and we have already specified the break width and break height. And now for the second break, which will be break rect 0 1, now I'm specifying the position of my second break as 150 50 and break width and break height. And now for the third break, break rect 0 2 and 250 and 50, break width and break height. Well, you guys should have noticed that why I'm using here very different values for x location on my break, 50, 150 and 250. Well, you do not need to worry about it right now. When I will run this program, I will explain this thing to you guys then. So you now just move along with me and type what I type. Break rect 03 equal to 350 50 break width and break height. Now just copy this and paste it again and again. paste, paste, 4, 5, 6. Yeah, 4, 5 and 450 and 550. But I think I should type here 7 instead of 6. 7. Now paste again, paste again, paste again, paste again, paste again. There we go. 5, 6, and now here it will be 1, 0, because we are now moving in another column. 1, 1, 2, 1, 1, 3, 1, 4, 1, 5, 1, 6. And now just moving to our third column, 2, 0, paste, 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 paste. Uh, 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and just paste it one last time. 2, 6. At last 150. Now we need to initialize the instances of our STL surface and STL texture for our break in our main function. So just go down to your main function a little more, and yeah, right here. Now just type here break equal to STL. I can't type well today. Oh my god. Load PMP, and the name of my that image is, what the fuck is this, break dot bmp, and now initialize value for STL, the instance of our STL texture, which is break texture equal to STL create texture from surface renderer dot break. Now this is the instance of my STL surface, and this is the instance of my STL texture, and I have initialized their values in my main function here and here. And where I have initialized these objects or instances, well, I have initialized them globally. Now we need to copy every break which are at different position on the screen. So just type here STL render copy renderer for this break texture. Now copy your first texture, which is break 0, 0. Now similarly copy your second texture, which means second break 0, 1. Control V, Control V, Control V. 02, 03, 04, 05, 06, 10, 11, 12, 13, 14, 15, 16, 20, 21, 22, 23, 24, 25, 26, 21, 22, 23, 24, 25, and 26. But I have done a huge mistake here. Well, these all must be copied in my game loop. So just cut it from here and paste it here. Now just go ahead and run it. I'm getting an error. Oh my god. This is because this is break rect and not break. Well, I'm pausing the screen and I will come back after I type all of my break rect instead of break. Welcome back guys. Now just go ahead and run it. And now I'm again getting an error. This is because I have forget to put this round bracket. Now again just go ahead and run it. And I'm not seeing any break. Well, I don't know why. Just close it. See what I've done wrong. Oh shit, I haven't called the initialize break function. So it should be called yeah, right here, initialize break. Now finally go ahead and run it. I believe that it should be now. There we go. Now our breaks are on the screen. And now let me explain you guys how I have laid down the position of my breaks. So I will minimize it and move to the initialize ball function, which is right here. Now for the first break, I have specified 50 for x-axis and 50 for y-axis. Open your STL window. Now the 50 and 50 location on my break is right here. And now what is the width of my all break? Well, the width of my all break is 80. So 50 plus 80 is equal to 130. It means that a break starts from 50 and ends at 130 because the width here is 80. So 50 plus 80 is equal to 130. So it starts from 50 and ends at 30. And now the space between the two breaks is 20 pixels. So this break must start from 150. So let's see where I have started my second break. Well, this is 150. So my second break is started at 150 and it will end at 230 because the width of my all break is 80. So it will end at 230 and again the space here is 2 and this break will start at 350 and end at 420 and so on. So this is how I have specified all the position of my break along x and y axis. I believe that you guys now understand how the breaks are laid down on the screen. Well, if you still have any query, please let me know. I will surely answer you through your emails and through my Facebook page. So For now, I want to thank you guys so much for watching, and I will see you guys in the next tutorial. Hello guys, my name is Bilal and this is your 16th STL tutorial, and this tutorial will be the most weird and hard tutorial of this whole course. So you guys need a lot of attention and brain in this tutorial. So open up your mind, tighten up your shoes and be attentive. Because in this tutorial, we will be detecting the collision of the ball with the brake, and as soon as the collision occurs, that brake should disappear from the screen. So first of all, instead of making this ball rect in my main function, I'm going to make it global. So just copy it, copy, remove it, and initialize it right here. Put a semicolon, and now I'm going to make a function called ball brake collision right here. Void ball brake collision, and it takes no argument. So first make a bool variable called a, and now we need to check the collision of the ball with any of the brake. So to check whether the collision of the bat with any brake has occurred or not, I'm going to make a nested for loop. Int I equal to 0, I is less than 4, I plus plus. For int j equal to 0, j is less than 7, j plus plus. And now assign a value to a bool variable by calling this function, which we have not yet created, ball brake collision detect, and it takes two arguments. And what are these two arguments? Well, these are the instances of our STL ball and STL brake. So just type here the instances of your brake rect and ball rect. Let's type here brake rect ij comma ball rect. And now why I'm passing these two instances to my function? Well, this is because the collision of the ball with the brake will be detected on the basis of the position of the brake and the ball. And now this instance contains the information of the position of the brake, and this instance contains the position of the ball on the screen. And now this function will return true if the collision take place, and this function will return false if no collision take place. And this true or false value will be stored in this bool type variable called a. And now why I'm using this nested for loop? Well, this nested for loop is for checking the collision of the ball with every brake. So when j is equal to 0 and I is equal to 0, check the collision of the ball with the first brake, and then when j is equal to 1 and I is equal to 0, check the collision of the ball with the second brake, and when j is equal to 2 and I is equal to 0, then check the collision of the ball with the brake at third brake. So now just make this function by copying it, copy and paste it here. Then the return type of it will be bool, because this function will either return true or false. And then paste it, and the argument will be received here. STL rect 1. Now again copy it because I am lazy. Paste it and rect 2. Now the arguments which we have passed from here, they will be received there. So now just make the body of it. Well, now let me first write down and then I will explain what I have done. If rect1.x is greater than rect2.x plus rect2.width, then control, then return false. And if rect1.x, rect1 and rect1, if rect1.x plus rect1.width is less than rect2.x, then return false. If, why don't I copy it? Copy, paste, and rect1.y, and hide here, and return false. And now just copy C, Control V, rect1.y plus rect1.height plus rect2.y, and all of these conditions are false, then return true. Now remember that this is my break rect and this is my ball rect. Now let me tell you what this .x with rect1 means. Well, I have told you that there are two ways to assign value to the instance of your STL rect. One way is to put this curly bracket and then assign values, and the other way is this way, that you type rect1.x equal to 10, rect1.y equal to 20, rect1.w equal to 30, let's say, and let rect2.h equal to 50. But since this rect1 and rect2 already has been assigned values coming from here where I'm calling this function, and there we go, right from here. So I'm checking only there. Well, I will explain only these two conditions, and I will leave these two conditions up to you guys to understand it yourself. Because if you understand these two conditions, then these two conditions are very, very similar to these two conditions. Well, let me first explain this condition first. And to explain this condition, I will open the ball image again. There we go. Now please consider that these are all of my breaks and this is the position of my ball. And now you know that the position of ball at this time at x is greater than the position of my break at x. In other words, the position of my break at x is less than the position of my ball at x. Same is the case here. I am stating here, if the position of my break at x plus its width is less than the position of my ball at x, it means that there is no collision, so you return false. And now this condition is stating that if the position of my break at x is greater than the position of my ball at x plus its width, then also there is no collision and you return false. Well, let us consider that this is your third row of breaks and the ball is now somewhere here. Now at that instance, the position of my break at x is greater than the position of my ball at x. So if this condition gets true, you simply return again false, which means again there is no collision. I hope that these both conditions are now clear to you, because it's not very weird. It's just simple. You just go through it again and again. You will surely understand it. Now just go to a ball break collision function. There. Now if a function has returned a true value, which means that the collision has occurred, if a equal to true, then you move that brick at X or Y out of the location of the screen, and you also reverse its velocity at Y. Velocity at Y is equal to ball velocity at Y. There we go. And now just go down to call this function in my game loop. Ball break collision. And now this initialize break must go out of my game loop. Control V. And now why it should be out of the game loop? Well, this is because the breaks should be initialized only once. There is no need to initialize it again and again. If I call this initialize break function in my game loop, then all the breaks will attain the same position again and again in every frame. And when the ball will collide with the break, then that break will go out of the screen in one frame only. And when this initialize break function will be again called in the game loop, then it will reset the previous position of the break in the next frame, and the break will come to its initial position again, and we do not want that. So now it's time to run it. So just run it. I'm getting an error. This is because I should capitalize this R here and here. Let's try again. And there we go. But the last two columns are not detecting collision. This is here it will be 7 instead of 5 because there are 6 columns. Let's run it again. There we go. Now it is beautifully disappearing from the screen. Well, I believe now that you guys understand everything. I know it's very weird for you guys, but if you don't understand, please guys go through this tutorial again and again as long as you do not understand. But I promise the next tutorials are very simple for you to learn. So stay tuned for this tutorial, and thank you guys so much for watching, and I will see you guys next time. Hello guys, my name is Bilal and this is your 17th STL tutorial. In this tutorial, we will be making the winning condition for our game. So for this, I'm going to make 2 global variables, and my first variable is delete break count and give it a value of 0. And another variable I will be making is number of breaks, and since I have 21 bricks on my screen, so I will type here 21. And now just go down to your ball break collision function. There we go. Now when the collision take place, remove that break from the screen, reverse the velocity of the ball, and increment delete break count. Now this variable is basically counting the number of breaks which are removed from the screen. And now just go down to your main function and just type here if delete break count is equal to number of breaks, which means that the breaks which are removed from the screen is equal to the total number of breaks, then go to the winning function which we haven't created yet. So just create your winning function right here, void winning. And now we will be displaying a winning image on our screen. So first create a surface for it, STL surface, Let's name it as when equal to STL load PMP, and the name of that image is when.pmp. Now create a texture STL, texture, texture STL, create texture from surface, renderer, and when. Now make STL rect for it, STL rect, and name it as when rect. Assign value to it, let's say 250 by 200 and 350 by 350, let's say. Now we need to copy this texture, STL render copy, renderer, when texture, null, ampersand, when rect. And now I'm not going to run it, because if I run it right now, your computer will be jammed after a minute or so. So in the next tutorial, I will show you how to stop jamming your PC. But if you wish to jam your PC for some time, you are most welcome. But I don't want to jam my PC. What I only want is to thank you guys so much for watching, and I will see you guys next time. What's up guys, my name is Bilal and this is your 18th STL tutorial, and in this tutorial we will be finally displaying our when image on the screen. But before we move to our real stuff, I will be making the instances of my STL surfaces and the instances of my STL texture global. Just like I have made the instance of my brick surface and the instance of my brick texture as global. So right now I am pausing my screen and I will come back after I made all of my instances of my STL surface and all of my instances of my STL texture as global. Now I have made all the instances of my STL surface and STL texture global, and all of these instances are being initialized in my main function right here. Now they are being initialized in main, but all of these instances are made global, and now we can use it anywhere in our code. So far whatever we have done, I have shared the whole code with you guys in a separate file, so if anyone is missing something, you can copy it from there. For now, let's move back to our winning function. Well, let's assume that we have won the game and we have deleted all the breaks successfully. Now at that time we do not need any STL surface and STL texture for ball, break and background image. All we need is this STL surface and this STL texture. So why not we destroy all of these crappy surfaces and texture to free the memory of computer. So to destroy all of the crappy STL surfaces and STL texture, I'm going to make a function called destroy. And now just make it here, void destroy. And now to destroy texture, STL is a built-in function called STL destroy texture. Now which texture you want to delete, just type the name of that instance. So just type here pad texture. Now copy it, Ctrl C, Control V, Control V. This brake texture, background texture, and ball texture. And now to free the surfaces, STL is a built-in function called STL free surface. So which surface you want to free, just name that instance as an argument. So pat, now copy it, pat, break, background, ball. And now just destroy your renderer as well, because we do not need any updates now. Renderer, similarly destroy your window as well. STL, sorry, it is destroy renderer, and here it is destroy window. Now just come down a little bit, and why not display this win image for 10 seconds on the screen. STL delay 10,000, which means 10 seconds, and after destroying everything, just quit the STL. And now why STL quit here? Well, this is because that after displaying the win image on STL window for 10 seconds, we do not need STL anymore, so just quit it. And why not use this destroy function here as well before quitting. And now I think that I have done everything which is needed for this tutorial, so just go ahead and run it. Oh shit, I should make this instance global as well, so just copy it and paste it right here. And now just go ahead and run it, and my win image should appear on the screen after all of my breaks disappear from the screen. Just be quick. On the 5 left, 4, 1, and there we go. We have won the game. Awesome and fantastic. And this window should quit after 10 seconds. There we go. Fantastic. Beautiful. And now you just keep playing this game and winning it again and again. But I want to thank you guys so much for watching, and I will see you guys next time. Hey guys, my name is Bilal, and this is your 19th STL2 tutorial. And in this tutorial I will teach you how the game over logic will work. So first let me run it. Now we will be allowing our ball to move out of the STL screen through this side only if the ball does not collide with the bat. And as soon as the ball passes through this side, we will definitely lose the game and our game will be over. So now let's see which condition makes the ball rebounds when it hits the bottom boundary or wall of the screen. So just close it. So this condition is the only condition which makes the ball rebounds after it hits the bottom side of the screen, because we are stating here that if the position of the ball becomes greater than the maximum height, and this background height is the maximum height, which I think is 600, so if this happens, you just reverse the velocity of the ball. So now we do not need this condition anymore, because we will be allowing our ball to pass through the bottom side of the screen if the ball doesn't collide with the bat. So now just run it to check whether it passes through the bottom side of the screen or not. And there we go. Just see that the ball passes through the bottom side and it is not rebouncing. And now if it passes through the bottom side of the screen, our game should be over. So in the next tutorial I will be making my game over function. Well, you guys should try it yourself, but I will do it in the next tutorial. So up till then, thank you guys so much for watching my tutorial, and I will see you guys. What's up guys, my name is Bilal and this is your 20th STL2 tutorial, and in this tutorial I will be making my game over function. And now when I will call this game over function, definitely when the position of the ball at y-axis becomes greater than the maximum height of our screen. So just tap here, if the position of ball at y becomes greater than the background height, which is the maximum height of our screen, plus 60. And now why this plus 60? Because let the ball to disappear from the screen and then call the game over function. For example, let us assume that this is the maximum height of our screen, and now plus 60 means that when the ball will be somewhere here out of the screen, just call the game over function. So if this happen, just call the game over function. So now just make the game over function void game over, and it takes no arguments. And now we need to create a surface, texture and rect for our image. So STL surface, go, which stands for game over, STL, load, PMP, and the name of my that image is game over dot PMP. Now create a texture, STL, texture, go texture equal to STL, create texture from surface, renderer, and go. Now create a STL rect, STL, rect, go rect equal to 0 0 background width and background height. Now STL delay and put it on the screen for 20 seconds. Then destroy everything. And then quit the STL, quit. And I believe that you guys know that why I have done this STL delete, destroy and STL quit here. Now one last thing we need to do is to create a prototype of this function. So just create a prototype right here, void destroy. And you should know that why I have created this prototype. But let me remind you, since my destroy function is beneath the ball collision function, so I need to create prototype, because otherwise the compiler will not know where this function is. Now one more last thing we need to do is right here, it's GOVER. Now just go ahead and run it, and there we go. As soon as the ball passes through the bottom of the screen, a game over image appears on the screen. Awesome. And now that our window will be closed after 20 seconds, and there we go. Our window closes automatically after 20 seconds. Fantastic. So now our game is almost complete, and in the next tutorial I will show you guys something else. So thank you guys so much for watching, and I will see you guys next time. What's up guys, my name is Bilal and this is your 21st STL2 tutorial, and in this tutorial I will explain you guys why I am using this weird instruction as an argument in my main. As I promised you guys that I will explain it in my starting tutorials. Well, the difference between the simple main and this main is that this main allows your program to accept command line argument. Many of the applications need to work with command line argument. Same is the case with STL. So many of the programmers use this main whenever they want to read a command line argument. Well, I have shared a file with you guys in which there is much detail about it. But even if you don't understand, then you can understand when you will learn some advanced and professional C++ programming, because I can't explain more than that because it will be a little advanced and this is only the basic STL course, so there is no need to go in the advanced stuff. Just remember, then whenever you are using STL in C++, you have to use this main. And now, are you guys curious about the challenges? So in the next tutorial, I will be giving you guys 2 challenges, and they are a bit hard for the beginners, but if you understood even 50 to 60% of this course, it's very easy then. So get ready for the challenges, tie up your shoes, and I will see you guys next time. What's up guys, my name is Bilal and here are 2 challenges for you guys. The first challenge for you guys is that initialize the position of the ball at the starting point of game so that your ball should be right above your bat and your ball should start moving only when you press the enter key. And you guys should know that all of your key presses will be handled by an event handling function. So for enter key, you have to type if event.key.keysymbol equal to STL K return, which means that if you press an enter key. And now another job I want from you guys is that when you press an escape key, your window should exit, and for the escape key you guys should need to type if event.key.keysymbol equal to STL K escape. And now your second challenge is that when all the bricks are removed from the screen, the next level should start, and the next level should have 21 or more than 21 bricks. Now one last job for you guys. You guys should be given 2 or 3 lives, so also try it yourself, and once you are done with these jobs, please share your code with others in my Facebook page and group. Well, I will share my code with you guys soon in my Facebook group and page. So start beginning your work as soon as possible, and I will see you guys next time. Hello guys, my name is Bilal and this is your 23rd and final video of this whole course. And in this video, I have something to tell you guys. Well, we have made so many stuff global, but you guys should know that it is not a good programming practice at all. It is highly recommended for some obvious reasons to make different structures for it. For example, make a separate structure for all STL surfaces and make another separate structure for STL texture. But what I think is that structure in C++ is a bit intermediate topic, so I haven't used structure. I made this code to keep things as simple as possible for you guys. Another thing I want to share with you guys is that you should be getting an error message as stl.exe has stopped working, maybe after 18 tutorials, but that doesn't matter at that stage. But why are you getting this error? Well, this is because we are not working on advanced STL. To remove this error, we have to be a bit intermediate. If you guys want to learn intermediate and advanced C++ programming, please let me know through my Facebook page and group. I will then surely make a C++ course from a very beginning to a very advanced professional level. Another course I can teach you guys is beginner and advanced Java and Python programming. I can teach you how to make Android and iPhone apps. I can also teach you scripting languages which are used for website development like HTML, CSS, JavaScript, PHP, Bootstrap, Node.js. All I need is your opinion. We can also learn advanced STL game programming, like we can make Super Mario Brothers, shooting games, flying games in 2D. Please guys, let me know. At the end, I want to say that it was a very nice and pleasant time with you guys. I hope that you guys should have enjoyed. So at the end, I want to thank you guys so much for watching my whole course, and I will see you guys in some other course.